So let me just quickly share my screen. Yeah, so the server framework is, I guess, is one of the more popular frameworks out there, and there's lots of others as well. You've got Amazon AWS SAM, you've got AWS CDK, you've got other, I guess, more opinionated frameworks that helps you build applications using Lambda and other similar technologies. You do have the advantage of using the server framework is that you do have this really big ecosystem of plugins that can extend what the framework is able to do. And that's something that's a bit unique to the server framework. Right now, it does have, if you go to serverless.com, it does have two different flavors. The pro version offers a bunch of other, I guess, useful things. So if you're just starting out and you haven't quite decided on what other tools you want to use, and you just want to have one framework that kind of do everything for you, even if everything it does may not be as good as if you were to find a more specialized vendor for, say, monitoring piece or for security or for CI/CD, but you have something that's all in one package, then by all means try out the serverless, the pro version. But for all intents and purposes, even for all the projects that I run in production, all I need is just the open source version. The open source version works just fine and has all the features you need to manage and deploy your application. And also, you can use a lot of the plugins to extend what the framework can do. I mean, for example, I've been doing a lot of work with AppSync, which is a managed GraphQL service that allows you to run to build the GraphQL APIs using Lambda, using DynamoDB, and so on, and you don't have to manage any servers. So with AppSync, it's not something that the server framework supports out of the box, but there are plugins that allows you to configure AppSync easily, and that's one of the advantage that server framework has over other things like SAM, like CDK, which is even though they may be open source to some extent, but you're still limited by just what the framework is able to do, as opposed to being able to extend it either yourself or through some third-party plugins. So with that said, I want to just quickly show you, given this is like a getting started in, session, I want to just quickly show you what you would do to I guess structure a project and to write functions and to deploy them using the serverless framework. We're not going to use AppSync. We're going to just use the basic API gateway with REST endpoints. So one thing I'm going to do is just quickly create a folder for this hello serverless. Okay, we've got a message in the chat here. Let's see, what is it?
Just
yeah, right. Okay. Yeah, we have Q&A at the end. So if any questions, we can just answer. Just put them into the chat, and then I'll try to pick it up later. So I'm using a VS Code, so I'm gonna open this up. Hello SRS in the VS Code. Oh, that's not what I wanted to do. Let's see. Okay. I was in that folder already. My bad. So one of the things, so if you go to the, let me close this one. If you go to the Server Frameworks website, it tells, I think, it tells you to install it as, you can install it from npm, and it may tell you to install as a global dependency to your on your machine. But I typically tend to install it as a dev dependency on a project, and using npm install or npmi save dev, and install it as a dev dependency on the project. And the reason why I do that is because I've had multiple experiences in the past whereby when the framework goes through a major version update, and I've got so many different projects, typically I will have one repo per microservice, and that microservice could be an API with multiple endpoints and therefore multiple Lambda functions. So one Lambda function that handles each individual endpoint and method, and then I'll have maybe some other Lambda function doing background task, but all within that microservice. And the problem comes when you've got a major version updates to the framework itself, in which case, okay, maybe the schema with which you need to configure your application is now different. So you end up being stuck in a place whereby if you ever need to deploy something from your machine, then, okay, which version do I need to run? I need to have multiple versions running side by side and so on. It just becomes a bit more difficult to manage. And then there's also the matter of on CI, what version do you install on CI and so on. So I just find it a lot easier if I install the server framework as a dev dependency in the project. And then we see how you can then also just use you can just use that to do to attach a debugger against your function code, and then run it locally as well. So one thing so first thing you've got to do is to create a new serverless project. Sorry, npx serverless create. So if I don't specify what template I want to use, from the error message, you can actually tell that the server framework itself supports multiple languages. It's got the templates for different cloud providers as well. So another thing that the server framework offers, maybe compared to some of the other solutions you find, is that it can work with other cloud providers. You can use it to make to write Python functions running on Azure, or to use Rust to write Cloudflare workers. So I want to clarify that this is not your solution to make a really portable functions that can run on any cloud. This is similar to the story you find with, say, Terraform, whereby the syntax with the specific syntax you use is slightly different depending on what cloud you're using, but you've got consistent tooling experience with Terraform CLI that you can use with any of the cloud projects you have. So similar idea here, that you've got a consistent tooling experience with the server framework, and then you can use that to create templates for to create projects based on some existing templates. Like if I want to create a project using Node.js function, writing Node.js functions that runs on AWS, I can create a template. Create a new project using that template, which initializes this YAML file, which is basically the manifest for my project, and that includes what provider, what node, what runtime I want to use, and I can override the default stage. If this is dev, staging, production, and default region I want to use. If I don't want to use US East 1, I can configure the IAM roles for my function, what permissions they should have. I can define environment variables that either gets applied to all the functions in the project, if I do it here, or I can configure them at the individual function level to say what environment variables that function should have. And importantly, I can configure that function's event trigger to say, please trigger this function when there's a HTTP endpoint, or when based on a schedule, or attach it to a SNS topic, and many, many, many more. Okay, so we don't actually need all of this. So if you get rid of all of that, you can also have some control. You can also put a lot of control around how you package your artifacts, so that you include what gets, you decide what gets included in your artifacts. You can also have other just raw CloudFormation resources that you want to provision. You can also just include them down here as well. Not just yet. I want to show you a very, very basic example of, say, let's create a HTTP endpoint. Oh, by the way, you see that I've got some IntelliSense support here. That's because I have installed the Serverless IDE VS Code plugin, which gives you some IntelliSense over and autocomplete support over the Serverless YAML. And if you install the CFN lint library, and also set up your IDE, Serverless IDE plugin to point to the runtime, then you also get IntelliSense support when you're working in this section and you try to create, say, a new DB table. So you get some IntelliSense support over here as well. So I know attribute name and the key type is going to be, it's got to be strings. So again, just comment this stuff out first. So I just want to have an HTTP endpoint that says the path is, let's keep it root, and then the method is going to be get. So I just want to have some very simple thing, and for Lambda function, the default. So in this case, you have you're writing a function that takes in some event, and in this case, which is returning a response payload that the API gateway is going to interpret as, okay, this HTTP 200 response with some body that says go serverless 1.0, even though now we're on 2.0, and then it returns the actual invocation event itself as input. So to deploy this project, so far what we've done is just created a very simple function in our project, and we've defined the trigger to be HTTP endpoint. So I can actually, before I deploy, I can actually invoke this function locally just to see what it's doing. Okay, so I say invoke local hello. Oh, sorry, my bad.
Happens all the time.
Yeah. So this is using the local version of Server Framework to invoke. The Server Framework CLI command lets you, has got a bunch of other things you can do, including invoking a function locally. And then, as you can see, that's the response from our function, which is good. This is what I expect. But input is empty, so I can pass in some data as well. So I can pass in some JSON data, just empty object, and then you can see that the input is returning the actual invocation event, which we said is the empty object. So what if I want to actually say put a breakpoint and then step through the code? You can also do that if I go to create a new launch config. I can get rid of this. Since we have installed the Server Framework as a dev dependency in this particular project, we can find the SLS, what do you call it, command line tool in the .bin folder in the node modules. So we can actually say launch the program node modules .bin SLS, and using the same arguments that we have used down here, which is the invoke local. So invoke local and -f for the name of the function, followed by the name of the function you want to invoke. And then when you do this, you do have to specify some payload. So when I do this, then I'm able to just say, okay, fine, let's put a breakpoint, and then I want to just run this up and then see, and then step through the code line by line, which I find very useful. For example, when I see some error in my application in production, for example, and I've got some, all this monitoring stuff set up so that I can quickly see, capture the invocation event. So I can then capture it, put it into a JSON file locally, and then just step through the code locally to see what's actually going on. So in addition to all the tests I have, I also can put a breakpoint in my code and just step through it. There's also plugins that allows you to run API gateway locally as well, so that you can simulate API gateway locally, which I find very useful for doing things like doing server-side rendering, because if I'm just returning JSON, I can visually inspect this and understand, okay, am I doing the right thing? But when it comes to server-side rendering, I can't render HTML in my head. So it would be really useful to have some local endpoint that I can point my browser to and just say, localhost 8080 or whatever, and have that return the rendered HTML. So that's something that I do sometimes with a plugin that lets you do that. So now that we've kind of verified that our function is doing the right thing, it's not going to error, let's do deploy. Before I do that, let me double check I'm in the right account so that I don't deploy to someone else's the wrong account. Okay, I'm the wrong account. So let's do that. All you have to do is run the npx serverless deploy command, and what it's going to do is it's going to package your entire project, but after it's excluded the dev dependencies you have in your package.json, so that if you look at the artifact that is going to get uploaded and the CloudFormation stack that is going to get created, it's going to be in the .servers.yaml, .servers folder. And if I open this in the Finder, oops, that's not what I wanted to do. I only open this in Finder. You can see it's only 71 kilobytes, and if you unzip this, the node modules has nothing, even though, if you remember, we had installed the Server Framework as a dev dependency, so there should be plenty of things here. And that's because as part of the packaging, the Server Framework automatically excludes any dev dependencies. If you're writing Python functions, Python has got this thing where the dependencies goes into this, well, you have your requirements or txt, and then the dependencies goes into a local folder, which oftentimes people find it a struggle to then have to extract those and include them in the artifacts so that your function has access to them at runtime. So one of the things that you can do is use a plugin for the server framework, which will basically do that for you, which is very handy when you're working with Python. So if you look at the template, the CloudFormation template that gets generated from our service YAML, it saves us a lot less writing in terms of code that we have to write, because there's actually bucket for the deployment artifact, there's a policy on that bucket, there's the log group that gets created for the function, there's the Lambda function execution role, which by default just gives your function access to create a log group and log stream, and then send logs to the CloudWatch logs that gets created. There's the Lambda function itself, as you can see, is pointing to some S3 artifact, because the server framework out of the box, it does the packaging for you, it uploads the artifact for you, and then it points the function you created to that artifact. Okay, and by default, it uses a 1 gig of memory and the 6-second timeout, which is pretty reasonable as a default, but you can always override this yourself anyway. And then you also create a Lambda a version, a mutable version for your function, so that every time you deploy, it creates a new version for you. And it creates API Gateway as well, which if you have seen API Gateway, you realize that it's one of the more complicated resources to configure, as there's quite a few things. You got to configure the REST API, and then every single method in between, and then so every endpoint, every resource along the path of the URL, and then you have to create a method for every single one of them, and then you have to create a deployment object that gets replaced every single time, which is why there's some random string at the end of it. So if you do this by hand with CloudFormation, then you often find that the second deployment doesn't actually update your API, because CloudFormation doesn't detect this as a new resource and then runs deployment. That's something that the SAM and Server Framework and CDK all have to apply this kind of trick. So basically, every time you run deployment, update the CloudFormation template with a new logical ID for this deployment object to trigger a deployment of your API, because of the way API Gateway works. And then you have to give the API Gateway permission to call your function, and so on and so forth. So there's quite a lot of different things that have to go in that you don't have to think about when you are just using the server framework. And if you look at the output of what we've just done, we've created a stack, we've updated that. It tells us what region, what stage, and then the name of the CloudFormation stack that we can find in the CloudFormation. I also provisioned this endpoint, which just a get endpoint that returns. Where does it go? Okay, it goes into my other screen. So let me just bring it over here. So when you hit this endpoint, it just returns that Go Serverless 1.0 message. Plus, as you can see, this is the invocation event our Lambda function received, and this payload is going to be different depending on what event source you use to trigger your function with. In this case, it's the API endpoint from API Gateway. So you get things like resource, path, HTTP method, and the headers, the multi-value headers, query string parameters, and the request context, which if you're using something like a Cognito, then you will also have then the identity of the user that's logged in. If it's a post, then you're going to get the body, which can also be binary. It doesn't have to be JSON or text. If it's binary, then this is basics for encoded would be true. Okay, so that's just something very, very basic if you just want to do like a REST endpoints. But you can also do, you also see a lot of people do server-side rendering with Lambda. So imagine if you want to do that, let's maybe do something like, let's call this get index to return some index HTML page at the root. So what we can do is I typically put my functions in a project into a functions folder. So I'm going to create one called get index. And what we're going to do in this case, not here, I want to create it at the root. Functions, I'm going to add the function called getIndex.js. I'm going to delete this guy. So that you don't watch me type, I'm just gonna copy some code I already have. So basically what we can do is we can just have a static folder. In this case, let's call it static. And I'm going to add a index.html file, which our function when it runs up the first time, what we call cold start, it will just use the file, the FS module to read that file and then return the HTML. So, just to show you that with Lambda and API Gateway, you can do more than just returning JSON and building REST APIs. You can also do server-side rendering. Imagine if you're using React or Vue or something like that, and you're using the React libraries to do the server-side rendering and then return the HTML itself as body of your HTTP response. And of course, I need the actual HTML here, so I'm just going to quickly grab something I already have prepared. Just very simple, like website that returns a few restaurants endpoints. Well, restaurants once we've returned some restaurants. But for now, let's just run deployment again. Prasanna, I think we only have got like 10 minutes left.
Yeah, I'm just upgrading the session.
Okay, all right. So let's see if there's any questions. Okay, no questions so far. So let's just wait till this finishes, and then we can see there should be a there should be an endpoint that returns the static page that we've just included. One thing also to keep in mind is that with Lambda, so all of your code still runs on some server somewhere, right? But the Lambda service itself is automating all of the process of allocating what they call workers, which essentially runs on micro VM technology called the Firecracker, which is open source thing by AWS. So what happens in that case is Lambda receives a request to invoke this function from API Gateway, so it creates a new worker. And as part of that, you have to initialize the runtime itself for Node.js, as well as your modules that you want to use for your function. So anything that's in the global space that's outside of your handler definition gets initialized during that cold start, during that first invocation. But then afterwards, after the function has finished, the node runtime itself gets frozen. And then the next request comes in, then that runtime gets unfrozen, and then it's used to execute another request, right? But anything that you already initialized in the global space that's in memory already, like the HTML string that we just read, they don't have to initialize again. So on a second invocation and third and fourth and so on and so forth, we just be running this bit of code. So we can initialize a lot of things that we want to reuse, including static configurations or static strings or dependencies, just once by loading them as part of the in the global space. So if I go back to the URL that we had earlier, okay, maybe I didn't have it here anymore. Now we've got this static page. So now we've got this static page. All it's doing is just showing something. And what if I want to have this page actually return some list of restaurants that you can then maybe place an order somehow? Then what we can also do is to create another function. Let's call this other function get restaurants to essentially be a REST endpoint that is going to return a bunch of restaurants from a DB table. So again, we're going to create, we're going to configure the events to be HTTP. I'm not sure what happened to the IntelliSense. So the path, let's just say, call it restaurants, and then the method is also going to be get as well. And then what we're going to do is we are going to say define a DB table in here. So let me just quickly copy some code so that you don't see me just waste time typing. So you've got this DB table. We're going to call the restaurants table, and it's going to be It's going to be on demand, so that we don't pay for them when we don't need when we don't need it. This just have got a name attribute. And in this case, what we can do is we can pass the name of this table as environment variable to this function. Okay, so what we're going to do, we're going to call this one. Let's see, restaurants table, and we can use the CloudFormation's ref syntax to reference this restaurants table, so that the name of the table is going to be passed to our function here as an environment variable called the restaurants table. So what we're going to do is we have to actually install the AWS SDK so that we can have this function talk to DynamDB at runtime. So we say npm install. We can say install the AWS SDK as a direct dependency, because at runtime the AWS SDK is already included in the for the function for Node.js, so we don't have to include it in the package size. Makes the package size a bit smaller. So we go to here, add a new function, get restaurants, and then we can just include something like this, which is just returning a bunch of, just doing a DynamDB scan to get, say in this case, 8 restaurants from the table, and then return that as JSON. Okay, so get the restaurants by doing a DynamDB scan, get 8 of them, and then return them as JSON. So we can have this endpoint that returns some restaurants that is going to provision, and to do that, it needs to be able to perform that DynamDB scan operation. So in that case, we have to add some IAM role statements. So we can add IAM role statements. Where is it? Okay, there you go. So we're going to add some permissions so that our functions can run DynamDB scan. All right. So let's once we've done that, let's run service deploy one more time so that we can check out this new endpoint. And then if we have time, we should probably, well, we can, if we have time, we can then also hook up the two. So I guess while we're doing this, any questions so far from anyone? I should also probably show you as well in AWS console the logs for our functions, which give me one sec, just grab my phone quickly. Because MFA and all that. Okay, log out. So I've got a question from Glenn here. Can you call third-party services for when setting up your provider? When you say call third-party services as part of setting up your provider, I'm not sure what you mean there. Do you mean from your Lambda function or from the CLI command line? Okay, so logging into my account. Oops. Okay, let's see. From Lambda, yeah, absolutely. So your function can make any HTTP calls that it needs to, and of course, if you need to pass in some authorization headers and things like that, then you have to manage those secrets and then make it available to your function somehow. Which is something that's usually I would do that by putting those secrets and API keys into something like SSM parameter store, and then have the function download and decrypt them at runtime, and then keep them in the memory so that it's never put into the function as an environment variable in plain text. So let me just quickly show you the logs for the function, so you can see the logs for the different functions. Oops, wait, hold on. What's going on here? Did I use the wrong one? Yeah, I used the wrong MFA code. Sorry, too many different MFA. Okay, so let's see. Let's go to Lambda. And if these are two functions we've got. So if you go to monitoring, and then you go to view logs in CloudWatch, you can see any log messages that our function has outputted. So anything that we write to standard out or standard error will be captured by CloudWatch automatically. So in this case, we are not writing. So so we deploy this restaurants endpoint. So now if we curl the restaurant endpoint, we're going to see, okay, it's not on my other screen again. We're going to see that it's going to return empty array for now because we don't have anything in our database, even though we were able to make the call from the Lambda function. So if you look at the logs for this function, functions, get restaurants, we can go to monitoring again, view logs in the CloudWatch. You can see that it's going to say fetching restaurants, trying to fetch 8 restaurants from this table. And this is a table name that's created by CloudFormation. So it's got that random bit at the end. So one of the things that we could do, if I want to run, let's say, a script that will seed some data into my table, is we can install this plugin for the server framework called the Serverless Export Env. What it does is it can extend. So once you install as a dev dependency, you can add it to the this plugins array, Serverless Export Env. And by doing this, this gives you a new command that you can run with the serverless CLI called the export env. And what it does is that it would inspect this CloudFormation stack that's been deployed, and then you capture things that are referenced by your function in the environment variables, as well as any output that you specify into a .env file, which is something that many people use with Node.js functions. So in this case, I can then say create a new script to see the restaurants. So even though the table names are going to be random, it doesn't really matter, because what we can do is that we can install a package called the .env, which is something that the Node.js projects often use to load in, data from this .env file. So in our little script here, we are just going to use that when you run require.env.config, that's going to inspect the .env file and then just load everything into environment variable for the current process. Okay, so we are going to create a bunch of restaurants. We're going to use the DynamDB client to basically just put them into the DynamDB table. So now I can run node, see the restaurants. And now if I go back to this endpoint, it's going to return those restaurants. And I can then just do some server-side rendering to make this page, make this Lambda function call this URL, get the restaurants, and then display them as tiles on this homepage. But I think we're already kind of over the 45 minutes that we were kind of planning. So I want to give you guys a chance to ask some questions as well, so that you guys got any questions around serverless development in general or the server framework, you get a chance to sort of get your questions answered. And I guess that Prasanna, do you want to make just let everyone else be able to unmute and ask the questions so they don't have to type in the chat?
I've given this unmuted everybody, so anyone can just unmute them and ask you.
Okay, cool.
I'll go first.
If you got any questions, please go ahead and ask.
Yeah, so in general, serverless architectures are becoming little, I mean, at least looking complex, right? There is API gateway involved. There is, if I'm using a Lambda, there must be an API gateway, and then sometimes there is an event bridge involved, and sometimes there is, it's better to use with DynamoDB, and then so many things, moving parts are involved, right? So how complicated could it get at an extreme level of, at an extreme production environment? Let's say I'm running, in general, I'm running an EC2 with 50 instances, but if I'm moving that all the code from 50 EC2 to functions, how it's going to look like? How difficult or?
Let's start by saying that it's not more complex. There's potentially more infrastructure components. But if you need to have a server-side rendering, if you need to have an endpoint that returns some data from that DB table, what are you going to do? You're going to have some code to do that, right? Or you're going to, yeah, right. All that's different is that now you've got a lot of complexity in your code that's running on EC2 instance that you have to manage. That you have to provision, that you have to configure the AMI, that you have to secure the OS, and that you have to also set up the capacity planning, make sure that you've got also scaling configuration correct, and that you have to do the multi-AZ and all of that. Versus what we just did, which is going to give us that scalability, that's on demand. It's going to give us the multi-AZ out of the box because Lambda functions are deployed to 3 availability zones out of the box, so we don't have to worry about that. And it auto scales. We don't have to configure anything for that. And it also gives us the ability to not pay for it when there's nothing running. So there's no capacity planning to work out what's the right number of EC2 instances we need to run so that we got the right, we hit the sweet spot for cost for when we don't have any traffic, as well as for be able to quickly scale up when we do have some traffic. So you get all of this out of the box. And the same with API Gateway. I don't need to run ALBs and all of that, everything that needs to be configured and paying for uptime. So is it more complex? In total, no. And if you look at what we just did, we just a few lines of configuration, right? So I think if you look at the architecture diagram, they can look more complex because there are more things on the diagram, but that's just arbitrary because of what we decide to include in those architecture diagrams versus what we don't. We don't include any complexities around what it takes to manage and run a containerized or application that runs on EC2. All the things that we talked about just now from a DevOps point of view, in terms of a security point of view of how to secure the EC2 instances, the networking around them, the OS itself, and patching and applying patches and all of that other stuff. Those things takes typically a lot more time, right? I've been working with AWS for over 10 years, and for a long time that was with EC2 and then with containers. And the amount of time you spend is easy 80-20%, 80% of on just infrastructure, boilerplate, DevOps type stuff, and 20% writing actual business logic. And now it's probably switched over to more like 90-10, 90% writing business logic code and 10% just configuring resources through service YAML and stuff like that. So
awesome.
In total, there may be more moving parts on the architecture diagram, but that's just incidental of what we decide to include in those diagrams more than anything else. So can you have really complex applications? Absolutely, but you can also that depends on the application and the architecture you decide to go with. What I would say is that the fact that serverless is really easy to work with, sometimes it does mean that you can create more complex applications because it allows you to do so in the same way that we all build more complex applications today than we do, say, 20 years ago, because the technology that we have available to us allows us and affords us the ability to build things that are more complex, but also that have more capabilities as well. And I think you find the same thing with serverless applications, in that sometimes they can be more complex, but because you're building more complex systems that can do more things, that's more interesting.
Exactly. Yeah, understandable. I got your point. Yes. Now, coming to, let's say, a best practice to follow, right? If I'm moving a bunch of applications from EC2 to functions, should I plan like in a way there is one function that is going to have one service that running, the other service will go into another function, or can I just move in like everything to one function because it's auto scaled, right? We don't have to worry about why would somebody go with multiple function scenario when you can just dump everything in a single function and you can execute it. I understand there is some limitation from AWS on the code base size, but apart from that, is it a good practice or is it?
No, it's not good practice. The good practice is to have functions that are small, that have a single responsibility. Now, if you remember what I just showed you in the Lumigo console, if there's one function that's erroring, you see which functions are erroring, right? Now imagine you have everything for an API that's got, I don't know, 10 different endpoints, all handled by one function, and you're just doing the routing internally. What happens then when something goes wrong? You're going to have all of your errors, everything, just pointing you to one function. But does that mean that is it the restaurant's endpoint? Is it the server-side rendering? Is it the endpoint to place an order? Is it the endpoint to load user's profile? You have no idea, because all of that is inside your code. You can't distinguish one error from another. In the same way that you can also not distinguish those requests for your functions, because it's all invoking the same function. So from a monitoring point of view, it makes your life a lot harder. From debugging point of view, it makes your life a lot harder. And also from a performance point of view, imagine you've got a function that needs to do all these different things. And I actually got some examples from a previous client I worked with, whereby they had an endpoint, API. They put everything to Express.js app, and then that app has got one endpoint that does server-side rendering, like we have here, but actually using something like React. And then they've got endpoints that just do a read from DynamoDB, do a single get item request. Everything was taking longer to cold start, because it's all going through the same function, and the amount of the dependencies you have to load, because every time you say require, that's actually a lot of I/O cores on the file system. Because we've added the AWS CK, for example, that could be tens of thousands of files you have to load from no module. That's a lot of I/O cores, and for something like React, it's even bigger. So that means that if everything goes through the same function, that every single invocation, every single cold start of that function requires you to load and initialize a React dependency, even if all you want to do is get one item from DynamoDB. So that's also going to have an impact on performance as well. And then there's also security. You've got one function that handles everything. That means that function have to have the permission to the broadest set of permissions required to do everything this API does, including writing and reading data from different DynamoDB tables.
Correct.
So if one endpoint gets compromised because it's got some vulnerability that allows someone to execute that's got code injection because using eval or something like that, or one of these dependencies using eval, then that means the attacker can do the most damage with compromising one function, as opposed to if that function can only do one thing, then you can only do, then you limit the blast radius of what that the attacker can do. So from security point of view, from being able to debug problems, also just from a performance point of view, it's better to have one function functions that have single purpose. However, if you're migrating existing application, I do understand the temptation to not want to have to rewrite everything to make it fit and idiomatic for Lambda. So as the first step to that for that migration, you just want to get some of the scaling, some of the DevOps benefits. Then just put your take a whole Express app running in Lambda. You can do that. There's frameworks that let you do that easily. There's also library that make it a lot easier for you to do that as well. But then take it as a technical debt. That is something that you have to repay at some point, that you have to refactor to make it more secure, more performant, and easier to debug.
Got it. Yeah, I think that's where the concern for somebody wanting to migrate to serverless comes, right? What if this is not going to work out for me, and then I have to again get the code back to work in EC2 environment? I think that's the thing. Okay, that's it from my side. Anybody else, if you have any questions, feel free to just unmute yourself and check with. I guess if there are no more questions, then I think like Glenn says, this has been great introduction into serverless for us. Yeah, thanks for doing this, and I hope I could have been a better host and then given better.
No worries.
But I myself have been stumbling. This is the first time I'm doing this, but I think next time I'll catch up and become better at this. And I will share the YouTube recordings and all those things with post in a couple of days with everybody as well as with you. And we will see if we can come up with something else to come and talk to us about the community, because obviously, as I was saying in the beginning, there are only a handful of experts that I have seen across in this ecosystem. So
there's
yeah,
quite a lot of people now in the serverless space that you can you can tap into. There's a lot of people that are doing stuff in production with serverless. Maybe not as many of them are quite as vocal and public as I am. But yeah, that's check out Jeremy Daly's podcast and my podcast as well, serverlesschess.com and realworldserverless.com. There's a lot of people who are out there sharing their real world experience of building serverless technologies.
Sure, fantastic. We will do that. Yeah, we'll keep you posted, and then probably we'll look forward to you to join as well in the future. And it would be better, if someone is talking about us and you're also there to take us through. That'll be great as well. So we'll catch up soon again, and thanks for doing this, and happy weekend. Take care. Bye bye. Thanks.
No worries. Yes. Bye bye.
Thanks a lot, guys. Thanks a lot for joining us. Take care. Bye bye.